Okay, hello guys. Welcome to our fourth Polkadot Sofia Meetup. This time it will be dedicated more for tooling, Cumulus and others, for developing parachains on Polkadot, and we'll be talking a bit more about Grandpa, which is Polkadot's consensus. So, okay, this is not working. What's Cumulus? It's a set of tools for writing Polkadot parachains that are based on Substrate. Basically, it's some kind of adapter for parachains, meaning if you have a Substrate parachain, you can make it Polkadot parachain. You can make it interoperable with the Polkadot easily. Okay, so we'll talk a bit more about Substrate because Cumulus is basically lying on top of it, so we need to have further understanding of what Substrate is actually is. So, as I've pointed out here, Substrate is the foundation of Polkadot. It's a standalone blockchain framework which allows developers to build highly advanced blockchains customized for any project. It basically gives blockchain developers a framework with minimal effort to build maximum freedom for building. And also it's highly customizable, adaptable, and made by blockchain developers for blockchain developers. So it also allows developers to focus on their effort on building the state transition functions, so the business logic of the whole parachain or substrate chain, while providing them with some built-in stuff like networking, consensus, and security, and as well path for interoperability with Polkadot. Let's try again. Okay. So, what is a state transition function? Basically, this is, as I said, the business logic that comprises the blockchain. It's a feature set, capabilities, and limitations. Depends on who or what the blockchain is for. And Substrate is basically designed to be general, to support a vast majority of present and future blockchain designs. So it is meant to be easier for a blockchain architect to start developing and not worry of all the other stuff besides the business logic. Also, Substrate, or the runtime that Substrate is generating of a blockchain, can be written in Rust, C++, or C. Substrate is expressed in a deterministic subset of WebAssembly, so it's designed to be lightweight, fast, and well supported. And yeah, some of us have tried it already, and some of you I know it as well. So I think you can basically see the speed and the lightweight.
Is it as easy as, can you develop as easy as in Rust with C++ and C?
I haven't tried yet, but I believe Rust will be much easier because Substrate is written in Rust.
Okay.
So you can basically, you can use more of it and be like, you can have easier way to develop in Rust because it's natively Rust.
Okay.
So yeah, I know I haven't checked what what other frameworks or parsers they use for C++ or C, but Rust is a bit simpler, I believe. So I think it will be easier. The networking layer that Substrate uses is built on top of libp2p, which is a modular network stack and works just out of the box. For blockchains that require additional networking, additional messages and stuff like this, Substrate are planning to release, to include a networking topology API in the future versions. So if your blockchain relies on complex or deeper networking, it will be available in the Substrate to make your own topology via their API. Another cool thing is that it supports vast majority of consensus algorithms, and also it includes Polkadot's Grandpa, which is the consensus algorithm Polkadot is using. It's basically an adaptive and progressive finality gadget, and we'll talk about it in a bit. Also, Substrate allows you to configure or change the format of the block and the whole database structure of the blockchain. So these are the consensus algorithms that it's supporting. Some of them are ready to be used.
The first one?
Rhododendron. This is from the flowers. Teaching като на цветенци.
Okay.
Okay, so yeah, these are the algorithms that, the consensus mechanisms that Substrate is supporting. Some of them are still work in progress, but they are planned to be supported, so I believe in the nearest future all of them will be ready to be used. We'll now focus more on Grandpa, but the others are somewhat overlapping with Grandpa. For example, these Ouroboros and Orand. The proof of work we all know about, which Ethereum uses, and the parachain is part of Polkadot Consensus as well. Okay, so yeah, Cumulus, the framework, the toolset that I told you a bit early, and that gathered us here, is basically currently supporting this Cumulus Consensus, which is a consensus engine for Substrate, allowing us to follow a Polkadot relay chain, meaning it will run a Polkadot node internally, and it can dictate the client and synchronization algorithms, how to basically follow, finalize, and treat the chain. These two things are planned, but the first one, Cumulus runtime, will be a wrapper around Substrate runtimes to turn them into a parachain, like validation code, and provide proof of generation routines and stuff like this. And the other, Cumulus collator, will be basically Polkadot collator for the parachain. So that was about Cumulus. More about Grandpa now. So Grandpa isn't just a cool name, it's basically an acronym for Ghost-Based Recursive Ancestor Deriving Prefix Agreement.
Oh,
Yeah, so this is the full name of Grandpa. They're basically marketing it as block finality in Polkadot. You will now understand why. So, for short, Grandpa is the idea of incorporating the blockchain structure into the consensus algorithm. So, in a bit, you'll know what I said just now. As classic consensus algorithms provide two main properties, safety and liveness. Safety is the property that ensures the honest participants don't agree on two conflict things. In this case, these are the blocks. So safety is the property that ensures every participant in the network agrees on the same thing. Liveness is the property that ensures something is eventually agreed upon by honest participants. So, in the context of blockchains, sometimes safety is the same as liveness, but that is once a block is finalized. The canonical chain will always contain the block in the future, and in blockchain, liveness sometimes means that the chain keeps growing, and furthermore, that valid transaction will eventually be included and finalized. So basically, this is the property that guarantees us that the blockchain will continue to grow and continue to add valid blocks after another. So for example, in proof of work or Nakamoto Consensus that we are used to, safety is technically never reached because the safety there is probabilistic. So all of the participants are agreeing on a common prefix property that states basically if each honest participant ignores the last k amount of blocks from their chain, from what they know, the probability that they agree on their chain is overwhelming, meaning with sufficient high choice of k, we will have a good amount of probability that this is the correct chain. This is basically it. There are many chains here, like proof of work that use this kind of probabilistic agreement, but each of them has a common prefix. Nakamoto Consensus, for example, ensures this, as I said, probabilistically. Grandpa ensures this deterministically, and now you'll see why. So, in order for participants not to break the safety and to revert blocks, I'll sit down. In order for participants not to break the safety property and to revert blocks, which have been agreed, public blockchains use incentive mechanisms. So they are rewarding the miners and the participants somehow. Opposingly of this, the consensus algorithm that Polkadot is using, for example, Grandpa now, they rely on majority assumption and use this accountable safety property, which they claim to be stronger. Accountable safety means in order to not break the consensus, everyone that is making some misbehavior and stuff like this is being punished. So basically they are held accountable, and this is providing a stronger finality. For example, consider a consensus protocol which is safe unless 1/3 or more of participants misbehave. As long as fewer than that amount misbehave, then everything is fine. But if they do, we want to be able to prove that they did misbehave. So that is accountable safety.
Does this mean that validators are not rewarded for validating?
You'll see in a bit. They are rewarded, but on certain conditions. So yeah, this is an example how the stronger finality works, and actually it brings this a block cannot be reverted unless at least 1/3 of the stake in the system is burned. So, for example,
and how can the stake be burned?
Normally, when the consensus is like architectured in Grandpa, for example, if you are a validator, you stake some amount of tokens that you basically guarantee that you will behave like normal.
Okay.
But if you are misbehaving, the collators can see that, and if they verify that you are misbehaving, your amount of tokens can be burned.
But not the whole amount.
The amount that you have staked.
The whole amount that I have staked.
Yeah, and the idea is that if you stake some amount of tokens of dots to be a validator, you will have like long amount of time that you need to wait in order for you to get it back. Yeah. And yeah, further in the presentation I have mentioned it, but I'll say it now because we are talking about it. The whole Grandpa algorithm relies on punishing the bad actors in time. So every time there is a bad actor, he needs to be punished. Otherwise, the algorithm safety is in compromise.
Okay, but if someone is misbehaving and someone else catches him that he's misbehaving, does this mean that if I misbehave and I successfully change something that I didn't have to, that this change will remain in the blockchain?
No. All the validation happens off-chain.
Okay.
The finality of the blocks is calculated off-chain and it's being agreed off-chain. And I will tell you in a bit how it happens. So, in a typical consensus protocol, we require a lot of messages to be signed in order to verify that all of the participants agree on certain condition. For example, if the block is valid or not. And they are passed around every time there is something to be validated. And often the number of participants can scale, and this can badly make it expensive to wait and for gas price and stuff like this to sign every message and announce it on chain. So this makes every agreement on every block be very expensive, and it's done differently in this kind of instant finality consensuses. Okay, so this approach leads to two things. First, Grandpa decided to separate the chain growth system, so the block creation is separated from the validation. The validation provides the finality, and this is a way for them to finalize as many blocks at once, like cheaper and efficiently, because it reduces the number of messages that needs to be passed around between consensus participants on the network. And this is the moment you can think about the liveness property we talked about. Since the finality gadget is not producing blocks, someone needs to take care of the liveness, what happens to it. And in order for not for it to not for this separation not affect the liveness property, they basically parsed it into to be dependent on some properties of the block. For example, in the block, you have some properties which the Grandpa Finality gadget, which is providing the finality and verification of the blocks, it's relying on. So you can, in certain way, verify that you always have the valid block and you will always have a new block to finalize. This is a very strong property because it means that we will always be able to add irreversible transactions in the chain.
Ooh.
I don't know if I explained it right, but
Yeah.
So when the validation is made off-chain, how we're sure that it is not compromised?
there are signed messages as well.
Okay.
You basically pass the signed messages, but they are not announced on chain.
Okay, they are passing signed messages between each other.
Yeah, and in a bit you can see how the validation happens.
Okay.
So Grandpa provides all this that we talked about and a bit more. Considering a block is valid implies that the block parent is valid. For example, if we know that block 25 is valid, we are sure that block 24 is valid as well because it's its parent. So based on this, in Grandpa algorithm, there basically the voting, this is the whole process of the verification and simplified version of the Grandpa, how it works. First, rather than voting on a single block, we allow every participant to vote on the highest block they think it's valid. So, for example, if you think that the highest valid block is 30, and Krasi thinks that the highest block is 30 as well, and I think that the highest block is 35, we have the 2/3 of supermajority that you agree that the highest block is 30.
Yeah.
So that automatically applies to all of other blocks that are below 30. And basically the algorithm agrees that we have now a majority of votes that are verifying that all of the blocks up until the 30th block are valid. So after this, it generated the proof of finality. The algorithm provides it. Right? And the proof of finality is basically constructed by taking these votes that we discussed and combining them in single bundled message with the signatures of all the voters. So this also is made simpler and smaller by aggregation of the signatures, and it takes less space, less bandwidth, and it's more efficient. And visually, it's like this. For example, here, node 1, we have here 3 forks now, and everyone is thinking that the valid block is the one he knows about, like the highest he knows about. But if we combine the 3 voters here, we see that everything starts from block C So we can basically assume that every block before block C is valid as well. And we can basically make a finalization of block C because everyone agrees that C is the valid block.
Yeah. Clever.
Yeah. Yep. And explained like in 1 or 2 sentences. Grandpa figures out via these voters if there is more than 2/3 of nodes claiming something is valid, like the highest block, takes the highest block that everyone agrees on and finalizes it. So it can also give different nodes different weights. If, for example, in the protocol is set like this, the highest stakeholder can have more votes, for example. If you stake more than me, for example, your votes will have much more weight. And yeah, in this diagram, blocks C, B, and A are finalized because everyone agrees on this. So how this is affecting Grandpa, it makes it adaptive. It can finalize new block regardless of how many blocks have passed since the block was finalized. So in the past example here, we can verify and finalize A, B, C together in a single iteration. Also, if we have low latency in the network, basically we can almost instantly finalize the blocks that we agree on. And another thing is that if we have a large amount of latencies in the network, so if we have network breaks and stuff like this, when we recover from these networking issues, Grandpa can finalize millions of blocks at once without any message overhead, because everything happens off-chain. And yeah, as I said, voting happens off-chain, and finality is not registered on-chain. So participants are staked on-chain. So every node, every validator is putting his stake on-chain, and this way, basically, conflicting proofs will lead to him being punished if he is misbehaving or double voting or stuff like this. This will punish, the network will punish him, and I'm not so sure how exactly it works, but this basically consisted of challenge and response protocol off-chain, which basically succeeds as how long a participant has been validating correctly and misbehaving and stuff like this, and calculating something of this, and basically determining whether he is misbehaving and whether he is not. This is kind of making it weak in subjective way of speaking, because as I said, we are relying on everyone to be punished when he is misbehaving. Yeah. Also, the protocol is designed that way for you, if you are a validator, to go through a long withdrawal window period, perhaps some few months, in order to unlock your stake. And this way, basically, is protecting the network. So if you're misbehaving, you won't be able to withdraw in an instant your reward. Yeah. This is Grandpa protocol, and these are some resources And yeah, now we can discuss unofficially.